Guys, Mrs. Heidenreich here, and this week we're going to be learning about factoring. So factoring is a special word that we use in math to talk about how to break down a number or an expression into its smaller parts, and it always involves multiplying or dividing. So for example, if we wanted to break down the number 12 into its factors, we would think of the numbers that multiply together to get 12. So like 1 times 12, or 1 and 12 would be factors of 12. 2 times 6 equals 12, so 2 and 6 are called factors of 12. 3 times 4 is 12, so 3 and 4 are factors of 12. 5 is not a factor of 12 because 12 is not divisible by 5. Okay, so that's the basic idea of what factoring means, but we're going to be learning about how to factor trinomials. So a trinomial has 3 terms. Our goal is to factor the trinomial into 2 binomials that when we multiply them together, we get back the original. Now, I'm going to start with the easy ones, which is when a equals 1. So when I say a, I mean the number in front of the variable that's squared. So this coefficient here is 1. So these are pretty easy. So when I do these, I just start by setting up my parentheses. And I know that I'm going to be filling in 4 spaces. Okay, because these are binomials, 2 terms. A binomial times a binomial that when I multiply them together, I get back the original trinomial. Okay? So, here we go. We know that these 2 terms, the first 2 terms, need to be b's, because if I multiply or FOIL or distribute back together, if I do b times b, that's what's going to give me a b squared. So these 2 first terms are always the variable, but just singular, so not squared, because b times b is going to be b squared. Now similarly, the last 2 terms, maybe I'll get a different color here, green. Those 2 numbers, remember from FOIL, or distributing back together, these 2 numbers, when we multiply together, they have to equal the c term. So this times this has to equal c. So we have to think of 2 numbers that multiply to get 7. And the only ones in this case would be 1 and 7. I can't think of any other numbers. It doesn't really matter if you put the 1 first and the 7 second, or if you switch them around, because remember that multiplication is commutative. And because these 2 first terms are both b, not like 2b and 1b, then it really doesn't matter. We're going to have a b and a 1 and a b and a 7. Okay, now we have to decide on the signs. So the issue here is that we need to get a positive 7 when we multiply 1 times 7. So I can either get that with a plus 7 times a plus 7, or a plus 1 times a plus 7, or a positive 1 times a positive 7. Or I technically could do a negative 1 times a negative 7, and that would give me a positive 7 in return. But these 2 numbers, when I add them together, have to give me b. Okay, the b term right here. So if I add a positive 1 and a positive 7 together, I get a positive 8. So let me prove this to you, that these 2 numbers, since they multiply to get 7, and since they add up to get 8, if I multiply this whole expression back together, so I'm going to go ahead and FOIL here. First times first, b times b is b squared. Let's see, if I do FOIL in that order, then I would do outside next. So that would be b times 7. That would be plus 7b. Inside terms would be 1 times b, so that's plus a 1b. And then last terms would be 1 times 7. So that gives me a positive 7 at the end. So I've got a b squared plus 8b plus 7 once I combine my like terms. So yahoo! It does. It matches the original, right? So this right here is my answer. That's the factored form of the original trinomial. This down here is checking my work. Okay? So the goal is to simply write our answers 2 binomials multiplied together. Let's go ahead and try the next one. I think I'm also using purple over here. For this one, I've got n's, n squared plus 6n plus 8. Okay, so I'm going to set up my two binomials with parentheses, and I'm going to fill in my first two terms with n's, because I know that n times n is going to equal n squared. Now over here, I have to think of two numbers that multiply to get 8. But I also have to remember that those two numbers have to add up to get 6. A positive 6 for this one. Okay, we're not really doing negatives yet. So, okay, I could do a 1 and an 8. That would multiply to get 8, but does that add up to get 6? No, it adds up to get 9, so I better not put a 1 and an 8. Let's try two other numbers, maybe a 2 and a 4. Let's see, or I could have done 4 and 2, 4 here and a 2 here. If I add those numbers together, will I get 6? Yes. So I've found two numbers that multiply to get 8, and then they add up to get 6. And they do both need to be positive, right? Because I need to multiply to get a positive 8. Positive 2 times positive 4 is positive 8. And I need to add them together. Positive 2 plus positive 4 is positive 6. Okay? Let's check our work here real quick. We'll use yellow. So let's go ahead and FOIL just to make sure we get back the original. N times n, n squared. Outer terms. N times 4 plus a 4n, positive 4n. 2 times n, well that's 2n, so I'm adding 2n there. And then lastly, 2 times 4 is 8. So if I combine these like terms here, I get n squared plus 6n plus 8. Yahoo! It does match, right? So I've checked my answer here, and I know that this is the correct factored form of the original trinomial. Okay, so that's pretty much it for factoring. I'm going to do some other examples, though, with some different methods if the problems get harder or with negative signs. So go ahead and watch our next video, but good luck this week on factoring.